In this lecture, we will discuss how we can obtain Fibonacci numbers using both iteration and recursion.
Let's suppose we have the following sequence of numbers. 1, 1, 2, 3, 5, 8, 13, 21, 34, and so forth. So let's say we're given the first two numbers of the sequence, which we'll say is A1 and A2. The nth number of the sequence, which we'll denote as AN, where n is greater than or equal to 3, is given by AN being AN minus 1 plus AN minus 2. So what this means is if we want to get A3, well, that's just going to be A2 plus A1. So if we use our sequence here, A2 is 1, A1 is 1, so 1 plus 1 is 2, so sure enough, A3 is 2. To get A4, we would take A3 and add A2 to it. Well, A3 is 2, and A2 is 1, so 2 plus 1 is 3. And we would just keep repeating this. So we're just basically saying that the third number of the sequence is the sum of the first two numbers. And then the fourth number of the sequence is the sum of the second and third numbers. And the fifth number of the sequence is the sum of the third and fourth numbers, and so forth. This type of sequence is a special sequence that we call the Fibonacci sequence. Now, the Fibonacci number sequence itself is very interesting, and there are several different applications for this in mathematics. But what we're going to do here is we're actually going to extend this for any sequence of numbers, not just that specific Fibonacci sequence. So if we're given any two numbers and we use this process, we can determine the nth number of the sequence. And a number that's defined this way is what we're going to call the nth Fibonacci number. Let's do an example. Let's say in our sequence we have that A1 is 3 and A2 is 6. So this isn't your typical 1 and 1 that we have with our normal Fibonacci numbers. So if we want to get A3, well, we would take A2 and add it with A1. So that's 6 plus 3, so that gives us 9. So A3 is 9. If I want to do A4, I would take A3 and add A2 to it. Well, from here we know that A3 is 9, A2 is 6. So if we add that together, that gives us 15. Now let's say we want to find the 10th Fibonacci number. Well, if we want to get the 10th Fibonacci number, we have to know what A9 and A8 are. But that requires us to know A7, A6, A5, and so forth. Let's take a look at the non-recursive approach for getting the nth Fibonacci number. So for our algorithm, the first step is going to be to get the first two Fibonacci numbers. So we're going to ask the user to enter in A1 and A2. We'll then need to get the position of the desired number in the Fibonacci sequence. So here we're going to ask the user to get the position n of the number of the Fibonacci sequence. We'll then calculate the next Fibonacci number by adding the previous two elements of the Fibonacci sequence. So in our first iteration, we would add A1 and A2 to get A3. We would then repeat this step, repeat step 3, until we get the nth Fibonacci number. And then finally, we would output the nth Fibonacci number. Now, for our purposes, we will assume that the first number is less than or equal to the second number, and both numbers are non-negative. That does make things a little bit easier for us.
Let's now take a look at the complete code for computing the nth Fibonacci number. So you're going to notice a couple things out of the ordinary, and that's because we're going to use dialog boxes for the input and output. You've already seen some examples of doing this in labs, so why not just go ahead and include in our code just so you can actually see it in action. So we needed the JavaX swing or javax.swing.j option pane in order to do the dialog boxes. We have a couple strings that will take care of our input and output strings for our dialog boxes, but the actual variables we need to do the Fibonacci numbers would be these right here. So we're going to need a prev1, prev2, current, a counter, and the nth fib. So this first part right here is going to take care of our dialog box for having the user enter the first Fibonacci number. So that's going to get stored in the string. So that means we need to convert it to an integer. So that's where integer.parseInt comes into play. So prev1 will have the first Fibonacci number. We then need to display the next dialog box to have the user enter the second Fibonacci number. So that's going to get stored in input. And then that means that we need to convert that string into a number. So prev2 will store the second Fibonacci number. And then we're going to create our output string, which will say that the first two numbers of the Fibonacci sequence are so and so. And then we're going to output the, we'll get another dialog box where we'll ask the user to enter the desired Fibonacci number. So that gets stored at input, and we convert that to an integer. And then we'll see at the end the resulting output where we say what the Fibonacci number is, and then the show message dialog box will display the actual Fibonacci number. So this will take care of displaying the dialog box with the output. Now, the main part of the algorithm is done right here. This section takes care of the bulk of it. So if the desired Fibonacci number is either the first or second one, we already have those values. So if nth fib is 1, then we know that it's going to be, our number is prev 1. Or if our nth Fibonacci number we want is 2, then we will say that our current is prev 2, and current is going to be the Fibonacci number that we want. Now, if it's not the first or second one, then we're going to use a counter here to determine which Fibonacci number we're at. So what we'll do is, while the counter is less than or equal to the number we're looking for, we're going to add the previous two numbers. We're going to take the sum of prev 1 and prev 2 to get that Fibonacci number. So like if this were the next iteration of the sequence, to get the third Fibonacci number, we need to add the first Fibonacci number and the second Fibonacci number together. And so current would store the third Fibonacci number. We then need to update the values of prev 1 and prev 2. So prev 2 would store the second Fibonacci number. And in this particular example, prev 2 would store the third Fibonacci number. We then increment our counter. And we just keep repeating this until we get the desired Fibonacci number. And that's it. That's all we got to do. So most of the work is done inside this while loop. So when we're done, our output would contain the value of current, which is the Fibonacci number that we want. So let's go ahead and compile and run this just to make sure everything works correctly. So this does compile, and then we'll run it. Here's our pop-up box. So here's the first Fibonacci number. So let's just use the normal Fibonacci number sequence. So that was 1, and then 1 as our second Fibonacci number. And let's say we want to get the 10th Fibonacci number. So I'll hit enter. So we said that the first two Fibonacci numbers were 1 and 1, and the 10th Fibonacci number is in fact 55. We can try this again if we want to. So we'll run it. And maybe we'll use a different Fibonacci number sequence. Maybe using one of our earlier examples, maybe A1 or our first Fibonacci number is 3. And then maybe our next one is 6. So if I want to get something like the 9th Fibonacci number, we would see that it would actually be 165. So sure enough, this does give us the nth Fibonacci number.